Our today's lesson is on solving quadratic equations by completing the square. We can represent a quadratic expression as a square in geometric terms using algebra tiles. Let's say this is an x by x algebra tile. We know the area is length times width, so we have an area of x squared. So when we see a big square, that's going to represent x squared. Let's say this has a height of x and a width of 1. 1 times x is x. When you see one of these rectangles, that's going to represent x. And let's say this is a 1 by 1 square. Well, 1 times 1 is 1. So one of these small squares will represent 1. All right, let's represent x squared plus 4x plus 4 using the tiles. I have 1x squared, so I'm going to put one big square. I have 4 x's, so I need 4 of these. And I'm going to use 4 of the 1's. So I could write it like this. If I were to, I can make a square out of this. So I can represent this as a geometric square by using the algebra tiles. This is like x plus 2 by x plus 2. All right, what if I asked you to complete the square of x squared plus 4x? With the tile, if I were to represent it using algebra tiles, you just have this, x squared, and you have 4 x's. But you're missing what needs to be there to complete the square. Well, we have a process for that. And what you do, you take the coefficient of the linear term, the number multiplied to x, and you divide it by 2. And that gives you 2. And the second step is that you're going to square the result. That gives us 4. That means you need 4 1's to add to this. That tells us you need 4 1's to complete the square. X squared plus 4x plus 4 is a complete square. Or you can write it like this, x plus 2 squared, since that equals x squared plus 4x plus 4. Complete the square of the given expression x squared plus 6x. Right? Our linear term is 6x, so the coefficient is 6. I'm going to take that divided by 2. That gives me 3. And then I want to square the result. Remember, the first step is to divide the coefficient of the linear term. And the second step is always square the result. If I square 3, I get 9. So if I complete the square, I'm going to get x squared plus 6x plus 9. Or I can write it as x plus 3 squared. One more. Complete the square of x squared plus 3x. Sometimes the coefficient can be an odd number, but you still go through the same procedure. This time I have a 3 for the coefficient of the linear term. I'm going to do the same thing. I'm going to divide it by 2, but 2 doesn't divide into 3 evenly. You're not going to make it to a decimal or a mixed number, but leave it as a fraction. Make sure it's reduced though, so 3/2, and then you're going to square the result. So 3 times 3 is 9, 2 times 2 is 4. So you get 9/4. That's what completes the square. So you get x squared plus 3x plus 9/4. Or I can write it as x plus 3/2 squared. Now we can use this procedure to solve equations. For example, solve x squared plus 8x equals 9 by completing the square. Well, if you look at this part of the equation, it's an incomplete square. You have x squared plus 8x. And what we're going to do is complete the square. But remember, what you do on one side of the equation, you must do to the other. So my my linear coefficient is 8. I divide it by 2. That gives me 4. Second step is I square the result. So 4 squared is 16. So now watch this. I'm going to go x squared plus 8x plus 16. But I have to add 16 to 9. I can write this as a square. I'm going to put x plus 4 squared. And 9 plus 16 will be 25. And now what you're going to do is take the square root of both sides. If I unsquare x plus 4 to the second power, I just write down the base. It's going to be x plus 4. And if I take the square root of 25, I get plus or minus 5. So now I have two equations. X is going to equal 5 minus 4, and x could equal negative 5 minus 4. Remember, I just simply subtract 4 to both sides. So x could equal 5 minus 4 is 1, and negative 5 minus 4 is negative 9. And these are your solutions to this equation. Okay, solve r squared minus 4r equals 165 by completing the square. We're going to do the same thing. My linear coefficient is negative 4 this time. So the first step is to take negative 4 divided by 2. It gives me negative 2. Second step is to square the result. So negative 2 squared is 4. So we're going to add 4 to both sides of this equation. So I get r squared minus 4r plus 4 equals 165 plus 4. You can write this as a square. And remember the patterns from when we did multiplying binomials. I have a negative and a positive. So this is going to be r minus 2 squared. And 165 plus 4 is 169. And we're going to take the square root to both sides. This gives me r minus 2. This is plus or minus 13. We have two solutions. We can have, you're going to add 2 to both sides. So r is going to equal 13 plus 2. Or r is going to equal negative 13 plus 2. So r equals, 13 plus 2 is 15. And negative 13 plus 2 gives me negative 11. And these are our two answers for this equation. Okay, solve p squared minus 3p equals 18 by completing the square? Well, like I showed you in the previous example about an odd linear coefficient, it's going to leave us with a fraction, but you can still solve equations like that. So my linear coefficient here is -3, and I divide it by 2. And then the second step is I square the result. So that gives us 9/4. You're going to add 9/4 to both sides of this equation. So I have p squared minus 3p plus 9/4 equals 18 plus 9/4. And you can write this as a square. It's going to be p minus 3/2 squared. But you got a little more work to do on this side. Remember, you need a common denominator, which in this case will be 4. So you're going to multiply 4 to the top and bottom. And when you do that, you're going to get 72 fourths. You're going to add that to 9/4. And when you add that together, you're going to get 81. 81/4 here. And p minus 3/2 squared. And you're going to take the square root to both sides. Now you remember with the fractions, you can take the square root of the numerator and denominator. So you're going to get p minus 3/2. You can get plus or minus 9/2. All right, so what we're going to do is add 3/2 to both sides. So p is going to equal 9/2 plus 3/2. And 9 plus 3 is 12. And 2 divides into 12 6 times. So one of our solution is p is going to be 6. And the other one is going to be -9/2. Get -9/2 plus 3/2, which is going to give us -6 over 2, which is -3. So your solution will be 6, -3. All right, solve y squared plus 3y equals 4 by completing the square. Here's another example where we have an odd linear coefficient. So you're going to do the same thing. You take 3 divided by 2 and then square the result. Gives us 9/2. You're going to add 9/2 to both, 9/4. You can add 9/4 to both sides. So you get y squared plus 3y plus 9/4 equals 4 plus 9/4. And you can write this as a square. That'd be y plus 3/2 squared. But you got to make this into a fraction. So multiply top and bottom by 4. So you can get 16/4 plus 9/4. All right, so you get y plus 3/2 squared. This is going to be 25/4. And you can take the square root to both sides. So you're going to wind up with y plus 3/2 equals plus or minus 5/2. So y is going to equal You're going to subtract 3 halves to both sides. So y could be 5 halves minus 3 halves. 5 minus 3 is 2. 2 over 2 is 1. So y is going to, one of the answers will be 1. And then you could have a negative 5 halves minus 3 halves. That gives us negative 8 over 2. 2 divides into negative 8 4 times, negative 4. So 1 and negative 4. This concludes our lesson for today.